So, okay, let's try one more thing right here. And if you thought that last trick with our synthetic division was pretty slick, I've got one more rule for you, which is actually really, really cool. And it's just that the synthetic division is good for more than just division. When we have this format, p of x divided by x minus a, we actually have a way of evaluating the function at that value of a. And the rule is this. This is called the remainder theorem rule. If a polynomial p of x is divided by some quantity x minus a, then the remainder is p of a. All right, so what does that mean? Well, in this case, we're asked to use the remainder theorem to evaluate f of 2 if f of x is the function x cubed minus 6x squared plus 3x minus 8. Right? So if we want to find what f of 2 is, right, by the rule above, it implies that we're going to divide by the quantity x minus a, x minus 2. Right? Now, if you recall, when we set up our synthetic division, the way it's going to go is that we're going to put 2, positive 2, on the outside. Why? I'm listening. Yes, you said it. It means that we take x minus 2, set it equal to 0, solve for x, and that's the number that we put outside there. Very nice. Then we take our coefficients. So our first coefficient is 1 from our dividend. Negative 6 is our next. 3 comes after that, then negative 8. And so let's carry this out. If we bring down the 1, we don't do anything to it, but multiply it by 2 in the next column to give us 2. Then we add going down the column to give us negative 4. We multiply 2 times negative 4 to get negative 8. Again, we add going down the column. That's going to give us negative 5. 2 times negative 5 is negative 10. And negative 8 minus 10 is negative 18. This last number right here is our remainder. So if it says use the remainder theorem to evaluate f of 2, by this rule, what we're saying is that f of 2 will equal negative 18. So this is a really slick way of actually getting the value of the function at x equals 2. We just carry out the synthetic division, and this remainder is the value of y when x equals 2. Pretty cool. Let's try it with this one right here. It says to use the remainder theorem again to evaluate p of 3. What does that mean? I'll listen to you for a second. What? Yes. It means use divide by x minus 3 again is our divisor. So when we carry out our division, of course, positive 3 is what goes on the outside. Here it is. And then on the inside, now be careful here. What goes in there? Yeah, 2. Oh, now come on. You remember we have to put a 0 placeholder here. Yes, exactly right. Then we put negative 4. Then we put negative 5. Okay, so what's going to happen right here? Well, let's carry down this 2. Multiply it by 3, so they give us 6. 0 plus 6 is 6. Take 3 times 6. 18 goes here. We add going down the column. That gives us 14. 3 times 14. I'll give you a moment for that one. Well, the answer is indeed 42. So 42 and negative 5. Now, let's see. 37. 37. Okay. So what we're really saying right here, of course, this is our remainder. And so how would we write the answer? Good. We write p of 3 is equal to 37 by the remainder theorem. Good luck in your homework. I'll see you in class.